Voltage. Voltage. Mathematically, voltage is not a difficult concept. However, it's sometimes kind of a conceptually ambiguous topic, and sometimes it's difficult to visualize what voltage is. So we'll kind of go through this slowly. As I said, mathematically, it's not difficult, so you shouldn't struggle with the questions. So there are many names for voltage. Voltage, electric potential difference, electric potential, or potential difference. They all are describe what voltage is. And what is voltage? Very simply, right here, voltage is the change in electric potential energy per unit charge. So that's why I say mathematically, this is not a very difficult concept. Voltage is simply the change in energy per unit charge. And that's how this formula is derived. We're just going to say, what's the change in energy per coulomb? In the same way that you would say the electric field strength is newtons per coulomb, right? This is just the change in energy per coulomb. So instead of newtons per coulomb, this is voltage is joules per coulomb. Okay. And the units for, we've just gone over them, the units for voltage are joules per coulomb, as we've just discussed. So this starts off nice and easy. Example 4 is just simply using the formula to determine the electric potential difference. So what you have to know is that when it says determine the electric potential difference, it's really asking for the voltage of a 3.4 coulomb charged object that gains that much energy as it moves through an electric field. So voltage equals delta E over Q. It's simply plugging in the numbers. 3.4, and that's going to give you an answer of 7.6 times 10 to the 2 volts, capital V, volts. Example 5 says determine the voltage if an electron gains 2.34 times 10 to the negative 15 as it moves between two parallel plates. So it's an identical question, except for this time they don't give you the charge. However, they do give you the charge because it says an electron. And as soon as you see the word electron, you go to your formula sheet, or you just go to your memory banks and you pull out that number, 1.6 times 10 to the negative 19. That's the charge of a single electron. You also have the mass of a single electron on your formula sheet. We don't need it for this problem, but just bringing that to your attention. Plug the numbers in, 2.34 times 10 to the negative 15, and divide it by the charge of an electron, and you end up getting 1.46 times 10 to the 4 volts. Okay, so that's the basics of volts, and we get in voltage. We get into more specific and more complicated problems in lesson 13. There's one other thing we need to do in terms of volts, and let's talk about electron volts, which again are going to be confusing because people see electron volts and they say, oh, that's a measure of voltage, is it not? No, no, no. Electron volts is a measure of energy. Sometimes it's not convenient to measure energy in joules, right? Because you're dealing with very, very small amounts. So we've come up with this new way to measure energy, and that is with electron volts. And what we're going to do is we're going to take the formula that we know the voltage equals change in energy divided by the charge. We're going to rearrange it for the change in energy. And then we're going to say that the charge, instead of writing 1.6 times 10 to the negative 19 for an electron, right, we're just going to say that this is the charge is 1 electron, right? And then we plug that number in here and we get this relationship. This relationship. And what is this relationship? 1 electron volt, we define 1 electron volt as the energy needed to move 1 electron through 1 volt of potential difference. So 1 electron volt is 1.6 times 10 to the negative 19 joules. And of course, it's not a coincidence that it's the same magnitude, the same number as the charge of a single electron. And that's why it's called an electron volt. An electron volt is how much energy does it take to move 1 electron through 1 volt of potential difference. Okay, and then on to question 6. And question 6, you can do it using the information that we just learned, or you can just do it the normal way, we'll call it, the normal way. So let's do it both ways. So let's do it the normal way, or the way that you would have done it before learning about electron volts. Determine how many electron volts, well, I guess you need to know electron volts in general, are needed to move an alpha particle through 20 volts of potential difference. So let's write down what we have. Determine how many electron volts. So what are we looking for here? We are looking for the change in energy. Electron volts are a unit of energy, not a unit of voltage. How many electron volts are needed to move an alpha particle? Soon as you see alpha particle, you write down the 2 pieces of information that you can get off your formula sheet about an alpha particle. An alpha particle has a charge of 3.2 times 10 to the negative 19, what am I doing, 16? Negative 19 coulombs, and it has a mass of 6.65 times 10 to the negative 27 kilograms. These are both from your data sheet, your formula sheet. And we're moving it through a potential difference of 20 volts. Okay, so we would do that, and we would simply say, we're looking for this, we've got this, and we've got this. The mass is irrelevant, and we can just use our formula. Voltage equals delta E over Q. Rearrange it for delta E. Multiply the 2 numbers together. 20 times 3.2 times 10 to the negative 19. And that gives us an answer of 6.4 times 10 to the negative 18 joules. Okay, but the question says determine how many electron volts. And we've got the answer in joules right now. We want the answer in electron volts. So we go up to here and just use that simple conversion that, again, is on your formula sheet. And the way I'm going to do it is I'm just going to say that if 1 electron volt equals 1.6 times 10 to the negative 19 joules, then how many electron volts does 6.4 times 10 to the negative 18 joules equal? And then I'm going to cross multiply and divide and get my answer, which turns out to be 40. 40 electron volts. Now, some of you are just going to say, well, if it's 1.6 times 10 to the 19 equals 1 eV, and I've got 6.4 times 10 to the negative 18, I'm simply going to divide those numbers, right, to get the answer. So I'm simply going to go 6.4 times 10 to the negative 18 divided by 1.6 times 10 to the negative 19 to get 40. I just like to use proportions because it makes me see things more clearly. Okay, that's the normal way. Well, that's not green. You could do it. If you want to do it kind of the shortcut way, using the information that we learned, you could do it this way. You could say that the voltage is 20, and you could say, since an alpha particle has an element is 2 times the elementary charge, you can just put this as 2. Multiply those 2 numbers together, and you get 40 electron volts. So that's kind of the shortcut. You have to do some rationalization there, or some justification that Q, instead of using the charge of the alpha particle to 3.2 times 10 to the negative 19, I'm just going to say it's 2 times the elementary charge. And that's kind of the strength of this little relationship that we did right here. Okay. Anyway, the works view is a good way. There is no right or wrong or better way to do that question. In fact, I probably prefer the long way in this one. All right, that wraps up lesson 12.